switching off my video. I'm sharing the screen. Yeah, can you see the shared screen, all of you? Is it visible? Is it visible, all of you? Yeah, can you see the screen? What I've shared?
Yes, sir.
Right now, the aim of the experiment is to yeah. So now we look at the experiment called compound pendulum. Okay, compound pendulum, you studied about oscillations in the earlier class. Okay, so we have seen oscillations in the theory class. For these oscillations, we have simple pendulum, okay, which executes simple harmonic motion. We have taken a bob. This is a rigid support, and from this, the bob can be dragged to one end and to the other end by a small angle. Okay, it will do oscillations like this. That's what we have seen. Next, we have seen spring mass system. Spring mass system. And in spring mass system, we have taken a spring attached to a mass M. Okay, and if you give some force to it from the origin, it will, from the equilibrium position, it will move. Now we will see here compound pendulum. Compound pendulum. Yeah. So in compound pendulum, it is slightly different from a string mass system or a string-like system. A compound pendulum will have a bar, okay, one meter bar. This is the steel bar having a mass of, suppose say, mass of this maybe 1 kg I'll take, or 1000 grams I'll take. This is the mass of the bar. Now, this bar will have holes at equal intervals, maybe of 5 centimeters each. Means from here to here or here, it may be 5 centimeters each. Holes will be there. And through the hole, you can keep a screw and you can hang it by the help of a screw on a this screw will be something like this. It will have a circular cross section, but it is made this side with a knife edge. On the knife edge, pendulum hangs. And hanging this pendulum can be oscillated by dragging it to either left side or right side. Then the pendulum starts oscillating in the given plane. And such an arrangement, we call it as compound pendulum. The aim of our experiment in this is to find out, aim is, okay, to find acceleration due to gravity g by finding equivalent length of simple pendulum after doing this experiment. Okay. So okay. First aim is to find acceleration due to gravity. Second part is to find, I'll say, radius of gyration. Radius of gyration. We'll find kg. We call it as radius of gyration. And the third point is to find moment of inertia of this pendulum of inertia. So I'll find it as. These are the three aims we have to find from this experiment. And this experiment, as I just informed, we have to take a pendulum and we'll oscillate the pendulum, and I'll calculate time taken for, you have to calculate a time taken for 10 oscillations, and find out the time taken for one oscillation, time period t, then find t, from which we will draw a graph. From here you have to, okay, important thing is that I'll keep the pendulum hanging at, suppose, say 5 first hole, and then I'll find time period. I'll keep it in the second hole, I'll find the time period, and the third hole likewise. As I'm coming down, the length of the pendulum changes, but this end I call it as end A, and this end of the pendulum as B, and A end is called reference end. You have to measure the distance always from the reference end, from the point of suspension. This is the point of suspension, and this is the height 5 centimeter when a hole is in the first, when the pendulum is hanging from the hole 1. If I keep it in the second hole, it will be, pendulum length will become 10. Likewise, I'll find it out. Initially, the time period will be higher when the distance is less, and as you are increasing the distance, the length of the pendulum, the time period slowly decreases and it becomes minimum at one point, then it starts increasing and becomes maximum at a point where you are approaching center of gravity of the pendulum. Once you move to center of gravity of the pendulum, the time period becomes infinity. Then I reverse the pendulum so that the remaining holes I have to use it and calculate the one. But while measuring, when I reverse the pendulum, okay, if I reverse the pendulum, then the pendulum will be something like this, okay, but B end here, A end here. You have to measure always distance from the knife edge. This is the knife edge where you are hanging the pendulum, okay. You have to measure now from here to here. This is the length of the pendulum. After doing this, you have to draw a graph by taking, okay, I draw a graph by taking on this length of the pendulum L. Then I take on this scale the time period T. And I start from maybe 0 is 5 s, okay. Likewise, it may be 50. I have, okay, instead of I write 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, because it's a 101. I don't take for 100, I'll take up to 95. So initially when you take the pendulum, this is the time period I'm taking, okay, time period I'm taking on this, time period I'm taking. So when you take the time period, initially for lower values, time period is high and it starts decreasing and becomes minimum, and then it increases to maximum like this. Okay. So it starts here, becomes minimum, and then increases, and then it becomes maximum or infinity when you reach the value of, when you reach near to the center of gravity of the. Okay, I'll just draw it again. Okay, this is. Similarly, once you reverse it, you will get the same curve here also, and this goes to higher value like this. Now I draw two lines. Okay, I draw two lines. So I take the two lines in such a way that the lines will cut the given graph at 4 points. I'll draw a line something like this. Okay, suppose this is this we have to take it. Okay, 4 point. This is the point, and I call this point as A, this point as B, this point as C, and this point as D. Now I find the distance from the graph AC. AC distance I'll find it, and I find the distance from the graph BD value, and then I'll take AC plus BD by 2, which I call it as equivalent length of the simple pendulum. Okay, and also I'll take AD distance and also BC distance, from which I can calculate a kg value. That is a moment radius of gyration of the experiment. Now we will see how to do this experiment, and I'll share now the screen of a video, okay, where you can see and take the readings. Yeah, Sonia, 49, roll number 49.
Yes, sir.
Yeah, you ask your friends why they are not joined. Still, some students have to join, 10 more students. Ask them to immediately join the class, lab class.
Yes, sir.
You send a message to them. So the simple pendulum equivalent length we'll find from the compound pendulum experiment, and thereby you can calculate the G value by using the formula G equal to 4 pi square into L by T square, where L by T square is the average value we'll take from the graph, which is from the equivalent distance, equivalent length of the simple pendulum. So if you see the experiment video, you can understand easily, and you can also perform the same experiment on the virtual lab. So now I will share the screen consisting the video, and go through the video and note down the values which I am showing here. Okay, and thereby you have to draw a graph. After drawing the graph, you should do the calculations. Right now, I will share the video. All of you go through it and inform me whether you are able to hear it and video is okay, visible or not. Yeah, dear students, today I am. So, dear students, can you see the video?
Yes, sir.
Yeah. Okay. So now I share the video. You just go through it and make note of the readings, whatever I'm showing there. So this is the compound pendulum. You can see, and you can do the experiment by noting the value. Yeah. Showing you a demonstration of an experiment called compound pendulum.
So you have studied in our first unit of theory that the waves and oscillations are one of the important aspects in our daily life. And we have seen the simple harmonic oscillator, damped oscillator, and also forced oscillator. In general, when you do some experiment, we have air friction, and thereby the amplitude of the oscillator slowly decreases and becomes zero, and this comes under the category of a damped oscillator. But if I suppose that the air friction is negligibly small, and then I can take it as a simple harmonic oscillator. And one of the most simplest simple harmonic motion can be shown by a simple pendulum. So this is the simple pendulum, I am showing it, and this is the bob, you can see it, and this is a string which is okay hanged to a fixed support, and the bob is here. And if I take it by a small angle and leave it, it will do oscillations. And this is for a system where the entire mass is supposed to be concentrated at single point and be hanged by a tensionless string. This is the one example of a simple harmonic oscillation, and this comes under a simple pendulum experiment. Now today I am going to explain about a compound pendulum. A compound pendulum is a bar just like this, okay, a bar having holes at equidistance mostly, and the distance between any two holes on this bar is 5 centimeters fixed. We have okay so many holes from one end to the other end. This is maybe around 1 meter steel bar having holes at equidistance, and it is now given with a knife edge, you can show it, through which we can hang this steel bar, which is called as a compound pendulum, where mass is distributed. Now you can see this is called as the knife edge. One of this here, if you see it, it is very sharp, where you have to hang the entire pendulum on the knife edge at a single point, and therefore the friction is minimum. And the other end, of course, you see it's not sharp. This is the sharp edge, which we call it as knife edge. So I am fixing this knife edge to the pendulum at one end. This is the one first hole I am keeping inside it, okay, and I am taking the other nut to this. I am fixing it so that the knife edge is exactly down, so that I make the pendulum to hang on the knife edge only on a fixed pivot or a rigid stand which is having a glass plate's ear. So therefore, I am just, this is the compound pendulum I am using, and I take this other compound pendulum, and I have the compound pendulum with equidistance holes and a knife edge. I am keeping this knife edge initially at the first hole, and from here to here, from the center of the hole, it is 5 centimeters. That's what we call it as the distance from the knife edge. So therefore, I am keeping here, and I just tie to this one at the first hole, and I hang it to the fixed bracket where there are glass supports here. Then these glass supports are there. So I keep this exactly in the first hole, and I'm keeping it here like this. You can see this, and see here this is the knife edge on which I am keeping it and hanging it. See, this is exactly parallel now, parallel to the wall. I am keeping this at a rest position, and I mark a line here, take it. This is the equilibrium position of the compound pendulum. Now, I will show you the tabular form and I will take readings and you have to note down the readings and to draw the graph and to calculate the acceleration due to gravity g using this, and also we can calculate radius of gyration of the compound pendulum. So once we did the experiment, we will get a set of readings from which we will draw a graph, and okay, we will see how to take the readings. Now look at the tabular form. This is serial number. I'll take many readings, and this is the distance between the one of the knife edge. Otherwise, I say distance from the knife edge. So when I take the distance between the knife edge, I call end A and end B the two ends of the compound pendulum. Always you have to measure the distance from end A to knife edge only, whether the end A is at the top or at the bottom. That is most important. Then I oscillate the pendulum and I measure the time taken for 10 oscillations with the help of a stopwatch. I count for time taken for 10 oscillations as a trial one for the first hole at a distance of 5 centimeters from the knife edge. And I'll see trial one, how much time it has taken, I will note it down. Then I'll do the experiment and repeat it, and I'll take trial 2 and I'll take the mean of the two trials as a time taken for 10 oscillations. But I want to find out what is the time period of the oscillator, or what is the time period of the compound pendulum. So I'll get time period capital T, I call it as in seconds, okay, by dividing this mean value by 10, because this is the time taken for 10 oscillations. To get time taken for one oscillation, I have to divide it by 10. That will be the time period. So distance from the knife edge is in centimeters, time taken for oscillations that we are taking mean in seconds, and time period is also in seconds. Now I'll show you how to take the readings. Now this is, I call it as end A. This is end A. The lowest bottom end is B. This is B. This is end A. I will measure the distance always from the knife edge to end A. Now end A is at the top. End A is at the top. Therefore, distance from here to here is 5 centimeters. So for the first reading, I have to take now the distance between the knife edge and this end A. End A is here. Okay, end B is here. I am always measuring the distance from end A only. So this is 5 centimeters initially. Then this distance, for this distance, I just give you that this is hanging on the knife edge. And if I just take it a small angle and leave a small, take a small angle and leave it, it starts doing oscillations. The precautions you have to take is that the oscillation should lie in the same plane. You should not make any oblique or going into a perpendicular plane or other planes. So therefore, once I take it here, this is the bar, I am taking this side and I just leave it. And going, coming back is one oscillation. Going and coming back is one oscillation. So I count for 10 oscillations. Going and coming back will be 1, 2, 3, 4, like this. But how much time it has taken, I have to say. For that, I take a digital stopwatch. This is the digital stopwatch. And now, if I press this, it will be 0. Then this button is for start. Once I start counting, then only I press this. So once I leave it, it goes, and then I start counting, then I press it. See, it is changing. So I count for 10 oscillations. Once I complete counting 10 oscillations, I stop. This I stop it. Okay, so I'm explaining. I'm making it 0 first initially. First, initially it is 0. Then I start counting. To start counting, I have to press this. If I press it, it starts counting. Okay, once I completed counting of 10, I stop it. I note down the time as 5.72, or how much it is taking for 10 oscillations, that I note it. Then I will stop it. Again, I'll take trial 2. For making 0, I have to press this again. This will become 0. Okay, so therefore, I am doing the experiment. You find it. So I stop here. And in the tabular column, first is distance from the knife edge from one end. This is A end, this distance is 5 centimeters. And second column are time taken for 10 oscillations. So I am starting oscillations, I just leave it going. So now I start counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I stop here. Okay. For 10 oscillations, it has taken nearly around 17.22. So therefore, I entered this reading for 5 centimeters, 17.22 as the reading. But I have to do it again as a trial 2 for the same distance. So I stop here. Again, it's a 5 centimeter. Then I take a small angle. I make this 0 by resetting it. Then I do it again this. So I am taking it and leaving like this. Okay. Now I start the stopwatch and I just to start counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now for this it has taken 16.38 seconds. So therefore I enter these values in the tabular form. So see how I am entering these values. First is 5 centimeters. I have taken 17.12. Next is taken 16.38. And I have to take the mean. Add them, divide by 2, you will get mean value. Time period, you have to divide the mean by 10 because time taken for 10 oscillation will get time period. You have to do all the calculations. Now I go for second reading by going to the next hole, which is again 5 centimeters down to the first hole. Therefore, this 10. Similarly, I go for 15, okay, I go for 20, I go for 25 by changing the knife edge into the successive holes. So each hole is separated like this, I go like this, and I go for 35, 8, I go for 40, then I go for 45, then I go for, okay, 50, okay, then likewise 55, and then okay 60, I'll go for 65 because it's a 1 meter one. I have to do for entire length of it as like this, and I go for 17, maybe 90, 18, I go for 8, sorry, this is 100. So each time I should find out the time periods only. First I have done it. Now second I do it for you. We will see, okay, what is the value. Now I am removing it from the stand or the holder. I am changing this knife edge. This is the end we have started. So I have to remove it and keep this in the second hole. I just remove it, I keep it in the second hole. Second hole is now 5 centimeters below the first hole. Therefore, if I say the distance from the knife edge, okay, the knife edge I have tied the knife edge here in the second hole and see from here to this end is our import. Okay, we start. This is now 10 centimeters. For 10 centimeters, I just keep it here. Okay, I hang it on the knife edge. Once it is hanging on the knife edge, I again do the experiment by again resetting this time watch to 0 and I start taking the values. So it is 0 now. I just give an oscillation to this and I leave it. Then it is while oscillating, I start this button. So I start counting also. So it has gone. Now it started 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 complete. Okay. So I take the value as 15.50. 15.50. Then I do it again. Okay. So to do it again, I have to reset this. I have to reset this and again I have to do the experiment for trial 2. So I am going here and see this, a small enter I have given. So now I am starting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I am getting nearly around 15.9. Okay. Likewise, I'll take the readings. Now, what we have to observe is that suppose say I am going to this foot. That means we started here. We are going to the center of gravity of the bar. So the center of gravity of the bar will be somewhere here. Then we have to see how the time period is changing when you are moving from one end to the center of gravity of this bar. I am just doing it here by keeping in this hole. Maybe at this one I am keeping it. So if I am keeping this here, okay. So after keeping this, if I see here, this is our end, actual end. So 5 centimeters, 10 centimeters, 15, 20, 25, 30, 35, 40 centimeters. Now I am at 40 centimeters from this end. So therefore, I keep it here and I hang it on the knife edge and I do it. See, I am doing it. I have to again count for 10 oscillations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oscillations. I again repeat it again. So I note down the time period taken. I am already writing the readings here. I will show you the readings later. You can note down those values. Now I will go somewhere here. So now it's 40. I go to suppose say 50 or so. So if I am coming here, I am keeping this here. And suppose say I just fix the knife edge in this hole and it is tightened and see 5 centimeters, 10, 15, 20, 25, 30, 35, 40, 45. Now 45 centimeters from this angle. So I keep it here and I try to hang this. And if I oscillate it and by a small angle, see I am taking and oscillating. The oscillations are taking too long time. So I say 1, 2, 3. I calculate time taken for 10 oscillations again. But now I will go to one more hole down. Okay, I will go. Means we are almost approaching the center of gravity of the bar, and thereby you can see that with approaching to center of gravity, the time period is increasing. That it is taking longer time to complete 10 oscillations. That means time period is increased. Now I have one here. If I go here and if I show here to see a hand here, okay, hang it here and I want to take the oscillation. So I just take it here and leave it. See now, it has gone to one side, totally one side. At what time it will come up? It will come down after infinity time. Therefore, at center of gravity, it has become infinity. So it will come after a long time it takes. Therefore, from here I cannot take any readings. That means up to 45 we have taken, 50 also we have taken. But what is the rest of the readings? How to take the rest of the readings? To take the rest of the readings, what I do is I now taken this end as a reference end or end A, and this we call it as B end, bottom end. Now what I do is I just remove this and I invert the bar. I will invert the bar so that our reference end will go down. It will go down and bottom well has come down. But I have to measure from here only. So therefore, I take it here and I keep somewhere here and note down the values, okay, of this. So if I keep it and write the values, now I have to measure the distance from knife edge to reference end. Reference end is here. So if I so the length will be 95 centimeters now. So therefore I keep it here again. I take in the same procedure what we have adopted to measure the values and I measure again for 10 oscillations. And then if I just change it and come to the second one, I just remove it, I will go to the second hole, third hole like this. I am going to fourth hole, so to say. If I am going fourth hole, the reference end is now down because we have inverted the bar. So 5, 10, 20, 30. So 5, 10, 15, 20. If I remove 20 from the 100 because the bar is 100 and 80. Now I am doing the experiment for 80 centimeters. So thereby I take it here and I note down the values. Again. Likewise, if I go again by returning to this one, okay, if I get it right here, and if I take it, the value of time period of this compound pendulum, we will get here again, okay, I'm holding it. But you can see that it is going to infinity. Again, it has gone to infinity. And but our end is here now. So always measure the distance from one reference end. Initially, the reference end is at top. We have gone down, and we have moved up to the center of gravity, and after that the period has become infinite. Then we have reversed the bar. Then we have to measure the distance from the bottom, okay? But because this is the distance between knife edge to the reference edge always. Then we have taken several readings. So these readings we have taken for each time, for time taken for 10 oscillations with the help of the digital clock. And then trial 1, trial 2, I have taken mean of it and you have to find T. From this, we have to measure the equivalent length of central pendulum and we have to calculate time period, the acceleration due to gravity. Okay. So, yeah, these are the readings I have noted down while doing the experiment. Okay. So the distance 5, these are the values I got. 10 centimeters, second hole, third hole, okay. And likewise, I have taken this for 20 centimeters from the knife edge, 25, 30, 35, 40, 45. After 45, it has actually become infinity. Therefore, I have started from 95, okay, or 100. So thereby, what I do generally is that these two I can remove. I don't remove because after that it has become infinity, and this also become infinity. So therefore, these two are not needed because the pendulum has gone to one side, and therefore there the time period is infinity. Therefore, I don't write the 50 here and 100 here. Okay. So this will be, of course, 95 I can write. 95 is 15.6 and 15.7. So 100 I don't write because it has gone. Okay, values. So therefore I note down these values. All of you make a note of these values for the distance and corresponding time periods. You need to calculate mean average of these two. Then divide this value by 10. You will get time period for one oscillation. That is called time taken for one oscillation is time period. Likewise, you note down all those values, okay, clearly, whatever I have measured now. Once you have noted these readings, you need to draw a graph. I will explain how to draw a graph and how to do the calculations. Now, with these readings, you have to draw the graph. So, I am taking on the x-axis, okay, length in centimeters. L is the x-axis. I am taking L in centimeters on this. Okay, this is x-axis. And we start from maybe 0, 5, okay, likewise, I'll go 10, okay, so on. I can go up to 100, this is 100 suppose say. I take this as 50, at 50 I draw a line and I take this as y-axis. On the y-axis, I take time period t in seconds. Time period t in seconds. Because we have calculated time period also. Then if you observe the graph or the readings what we have taken from the experiment, initially when we started at 5 centimeters, will have higher time period. As you are moving towards the center of gravity, the time period decreases. At certain value, it becomes minimum, and after that, it goes on increasing and becomes maximum. This is from, okay, I say 5 to, okay, 50 or so. It becomes maximum. Comes maximum, decreases and becomes minimum. And now after 50, we have 95 onwards readings. So 95 may be here. So here at 95, this is higher, and then it slowly decreases and becomes minimum and goes on increasing and it becomes maximum. These two are symmetric. So we have a graph like this. So this is from 5 to 50 or 45. This is 50 to, okay, 95. So we'll get a graph. That means initially the time period is higher and it slowly decreases and becomes minimum at one point, and then we are approaching the center of gravity, it becomes infinity or increases to very fastly. Now here I have taken time period t at different values. This is the time period. Now I select a line in the graph so that that line cuts these four graphs at, okay, this graph at 4 points. So I am dragging here. So I call this as point A, I call this point B, and I call this point C, and I call this point D. Okay, sorry, D I take it as. I also take another line parallel to it, slightly either below or above. I can take it. Then I call this as A dash. I call this point as B dash, this as C dash, and this as D dash. Now, to find acceleration due to gravity, I have to find the equivalent length of simple pendulum from the compound pendulum. We have done compound pendulum experiment. So, I would like to find out equivalent length of simple pendulum from the data of the values of the compound pendulum. To do that, I will show you use this table. So see AD, this is to find the value of G from the graph. I am finding equivalent length of simple pendulum. That means if you make a simple pendulum with this length, it will have same period as that of the compound pendulum we have calculated from here. Now I choose this graph. This is A and I know this, suppose say it is at 6. I know deep, C point. Alright, I now take the point D, A, B, this I call it as AC, suppose, or according to the tabular form, I am remodifying it A, B, I call it as C, I call it as D, and I call it as E. But it does not matter what we are taking. We want length between these 2 points and these 2 points only. So I find out A and value D. So what is the value of D from the graph? Suppose if it is 65, suppose it is suppose 7, I subtract 7 from 65 and that value will be AD. I have to find AD value. And also I'll find BE value. Suppose B is at suppose say 30 or 40 and suppose say E is maybe around 100, so 60 will be there. So I have to find the value of BE for the first line. And similarly I have to find second line A dash, D dash value, this will be C dash, and E dash value I have to find it out. So thereby, if you go to the tabular form, you need to enter AD value, BE value, and you have to find mean of this, which we call it as EF, is equal to AD plus BE by 2. That is the length L. And see here again on the graph, come to the graph. This is the corresponding time period for AD and BE. Because we have taken on y-axis the time period. Y-axis is time period. This may be suppose say 12 or something, or maybe 15. Suppose say if I'm taking 15. So this value will be the time period. Corresponding time period I'll enter in the tabular form. For the second line also I'll find AD distance and also B or A dash, D dash and B dash, E dash values. And corresponding time period is time period on the y-axis where it is cutting. This is the corresponding time period, and therefore I go and enter those values AD, BE for the first line and for the second line, and I take the time periods here. T I'll get from the y-axis. For the second also I'll get from the y-axis. 1, 2. Then I'll get time period. And now to calculate the value of G, we use the regular formula to find the value of G. That is here G, G is equal to 4 pi square L by T square. So L by T square we have to find from the second table, and we have the second table here. Therefore, I put here, this is L I am getting and this is T I am getting. I add one more column here to get L by T square. So this is T and T square, you know it. L is this value, T square of this, L by T square will get it as. So we'll get L by T square, L by T square. Then G have to find out. You have seen the formula for G is equal to 4 pi square L by T square. So L by T square from the tabular form, if I substitute it, I'll get the value of G for the first line. and enter here. Similarly, for the second line also I enter G value and take now average G value. That is the result for you. Okay.
Yeah, students, did you follow the video? So now we will do the same experiment on virtual lab. All of you open Google Chrome. I'll share my system. Roll number 18. 18.
Sir.
Can you see the screen?
Yes, sir.
I'm just sharing the screen. Okay. So we go for this. Yeah, all of you, can you see this? And I'll type here Amrita lab or virtual lab. So I'm going for virtual lab. Virtual lab, compound pendulum. I'll go for compound pendulum. So here, compound pendulum. All of you got this? And the theory part, I'm clicking here. Okay, so first we'll go for procedure. Yeah, how many of you can you see the virtual lab what I have shared? Got it, all of you? 45, you got it. Yes. Raise your hands. Who has opened your 20? Good. So this is the procedure. You just go through the procedure. Okay. And the tabular form is same, whatever we have used. And these are the values. You have to find it out. G, I explained using this AC. This is AC plus BD by 2. That is mean we have taken, from which you can calculate the acceleration due to gravity by using our formula. But here that is G is equal to, okay, this is where they have given G is equal to this value. You can calculate this, okay, this value. Now 4 pi L by T square. Now we have to find out radius of gyration of the pendulum. So how to do the radius of gyration? He has given C, H equal to AD by 2, H dash is equal to BC by 2, they have given here. And radius of gyration is square root of H1 H dash. Okay, this you have to say it. So therefore, okay, go to the graph. From the graph, they have taken, see, AD by 2. A is this value, D is this, by 2 they have taken, and also BC by 2, B is this, C is this, BC by 2 they have taken. There they call them as H and H dash, and where kg is radius of gyration about the center of the mass of the compound pendulum, H dash root, that we have to do. And to calculate moment of inertia of the pendulum, Moment of inertia of the pendulum about the center of mass, Ig, is equal to m kg square. Here m is 1 kg, mass of the pendulum is 1 kg, and kg square means here is center of that is radius of gyration. You are finding radius of gyration from this table. So all of you go to the procedure, note down the tabular forms and also formulas how to calculate this. So you have to calculate from our graph the readings from the video. You have to calculate G, moment of inertia, and kg. And you have to do the experiment virtually, and then you need to do all these calculations again for virtual lab. Therefore, your record should contain both the values from our video and also from the virtual lab. But however, this virtual lab to do the experiment, okay, this simulator is not functioning correctly. Therefore, I will give you another site, okay. I will share that site where you can do the same experiment and you can take the readings. But to do calculations or to note down the values, you have to use these tabular forms, and the result you have to use this. Okay. So now I'm going home and I'll just find it out from the bookmarks. Okay. We have one such uh, otherwise I'll go back. Yeah, you click this. I'm sharing this link in the chat box. Okay. Yeah, use this link to open the simulator. So the simulator is here. I click for the simulator here. Yeah, all of you, can you see this screen? This new screen? Yeah, can you see this? All of you? Yeah, good. How many can see the screen what I have shared here with the simulator? You raise your hands. Good. Yeah. So I am going here. I will tell you how to do the experiment. Now the variables are there. Variable is only length. If I just is 5 centimeters already fixed. If I go for, I'll go for it 10, 20, 30, 40, 50. But here it's come down because the pendulum is reversed. Okay. So I'll just put this 5 centimeters and acceleration due to gravity. I can choose Moon, Uranus, Neptune, Pluto, Jupiter. But I'm doing the experiment for Earth only. You can choose it. And to do the experiment, you can, okay, stop, okay, start this one by starting this time period. This is hours, minutes, seconds, milliseconds. So now the L, the length is 5 centimeter. That is first hole hanging from the knife edge. I leave it and you have to start from here. So whenever it is coming, this end I start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I stop it. This is the 16.073 is the time period. You have to note down this. This is for first one. That is first try. Then I stop it here. I can also click show result. For this value, G, they have taken 9.8. Radius of gyration, they got 0.25, but you have to do calculations. And moment of inertia by taking M equal to 1 kg, they got this. Okay, but however, this you have to do the calculation. Don't write the values right like this. I have done only for one. So I just stop it here. Then I have to do for the same value second time. I take it here and leave it. Then I start counting 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So you note down the value again this. Okay. Likewise for 5 centimeters. Then stop this. Go to 10 centimeters and do the experiment. Okay. But while doing the experiment, once you give it, so once it comes to some year only, you have to start it. Okay, just come and then start it. Then count for 10 oscillations. Once it is stopped, stop it. You can make it 0 also by doing it. And then after 10, go for 15, 20, 25. See, as I'm increasing, the bar is also moving up. And 20, 35, 40, 45, 50, I'll go. And if I want to do this, see this, I'm doing, this has gone one side. As I have shown in the video also, this become infinity. Okay, it will not come. But if I go for, suppose say 45, you see it, it's very slowly taking long time. Then I go for 50. Okay, if I leave it, it's gonna. If I go for 55, and okay, it's doing again. 55 now, which is you have to take measurement in reverse end. That's what 55. Then I go for 60. Okay, 65, 70, 75 like this. It's coming. Likewise, I can take it. So now the measurement is from this end to this end. 90 means this is the 90 because end is reversed, and I can go for 95. So take the values, and each time you have to take the values for two trials, trial 1, trial 2. Enter these values in the same tabular form which is given in the procedure of this experiment, as well as this, it is also same as given in our video also. So do the experiment by keeping this yet. Otherwise, you can find it out on other planets also, including the satellite moon. Okay, so you can choose any planet. You can do it, and you can calculate the result. If you want to do it, stop it. Okay, reset this one, and I'll do the experiment. And if you want to find the result, okay, you can also find the result by doing it. So how many are able to do this, show this, see this and do the experiment? Now take the readings. You have to take from 5 centimeters to 100 centimeters each time. Trial 1, trial 2, take mean and enter the values of the time period. And start sharing the screenshots, those who are doing this experiment. Okay. Yeah, only few people are able to do this experiment. What about others? 27. Roll number 27. $35. Are you doing the experiment? 35.
Yes, sir. Yes, sir.
Yeah, 35. Do one thing. I make you presenter, share your screen and show me the video. I'm making you a presenter. You can share your screen. Can you do 35? Can you share? Yeah, 56, you are doing it. Good. 20 also. 46. What up? 18. 22. What happened? 38. 38. Those who are doing online the virtual lab, raise your hands. Yeah, roll number 28. Roll number 28.
Yes, sir.
Are you doing? Can
Yes,
you
sir.
share your screen? Sai Krishna, what happened? 35.
Sir, I don't know how to share the screen, but I have shared the screenshot, sir.
No, 35.
Sir,
Yeah.
I don't know how to share
No.
the
I will.
screen, but I
No. I will let you know. Don't worry. I'll make you again the presenter. Okay. You have a video button here. A red button. Leave
yes,
is
sir.
there. Leave. After that, there is an arrow mark. Can you see the arrow mark? Okay. Sai Krishna, I'll make you a presenter. Then you'll get a. Okay. Yeah. I'm making a presenter. Yeah. Can you see after the video icon, you have a mic, and after that there is an arrow mark. Is there? Then click it. You can share your screen. Are you able to do it? So I'm stopped sharing my screen. You share your screen. Yeah, all of you take the readings from the virtual lab. Yes. Srija, 51.
Yes, sir.
Can you share your screen?
Sir,
And show
actually,
me.
I'm doing it in a laptop. Can I on
Ah,
my video?
yeah, you can on the video.
Okay, sir.
Okay, no, you can not switching on the video. You can share your screen, whatever you are doing it. I will make you a presenter. Once I make you presenter, you can share your screen. Okay.
Sir, I'm listening in mobile and doing in laptop, sir.
No, that's why. Okay. Otherwise, you switch on your video and show me how you are doing.
Yes, sir. Give me the permission for
Yeah,
video.
I'm giving. $51. Just a minute, I'll give you permission. Yeah, I'm getting your video. Just down it. Yeah, you focus it. Yeah, good. You just turn it upside down. Your camera is showing you upside down. You just tilt your camera. Yes, yes, good. Yeah. Oh, 75 centimeters you are doing. Just give some oscillation to the pendulum. Yeah, good. Right. Take all the readings, Srija.
Yes, sir.
Yeah. Sai Krishna, can you do?
Sir,
Yeah, you can share your screen. Otherwise, you show me your
video, sir.
yeah video. You can switch on video. Share your video. Yeah. Show me the screen. Good. So what is the length? 5 centimeters you're keeping? Okay. Also share your screenshot. Good.
Okay, sir. Sure, sir.
Okay, okay, good, good. 19, Kalyan.
Sir.
Have you done the experiment? Did you share the screenshot?
No, sir, I'm doing, sir.
You have not shared the screenshot so far. Roll number 6.
Yes, sir. I've shared it.
Shared it. Are you taking the readings?
Yes, sir.
Yeah, take them quickly. So all of you need to take all the readings, both from the virtual lab and also from the video. But anyway, video readings are already there with you for doing any calculations. But virtual lab readings, you have to do it and make a tabular form and enter all those readings in your record book. And you have to submit the record, both virtual lab readings and also the video readings. And next week, you will be coming to the lab physical mode. And while coming to the physical mode, you should bring your record with all completed experiments, which we have done online, along with the calculations. And write all those online experiments in the index sheet. And also put the dates in the index sheet. And I have already given marks in the teams. How many marks you got? You write the marks also there in the index sheet itself. We will sign after verifying. Roll number 4, Ananya. Yeah, roll number 3, Akshat.
Yes, sir.
Are you doing the experiment? Are you able to do it?
Doing, sir.
How many readings you have taken?
Now only just started, sir.
Share the screenshot in the chat box.
Okay, sir. Okay, sir.
Srivardhan, 2038. Are you doing?
Yes, sir.
Did you share the screenshots?
Yes, sir.
Yeah, do it. Baddu, roll number 8. Bharat Kumar, 9. Roll number 30. Pratik. Raghavendra, 31. "31. 32. Rajshekhar.
Sir.
So are you doing?
Yes, sir.
Did you share the screenshots? Ajay, you have sent. 33, Rishi Kumar. 34, Sai Kiran.
Sir,
Have you shared the screenshot?
no, sir. I'm still doing, sir.
Are you getting the readings?
Yes, sir.
Yeah, good. Do it. 35, okay, done. 36, Nikita. 36. Roll number 36. 37.
Yes, sir.
Have you done Saket?
I'm doing, sir.
Are you getting or any problem?
I'm getting.
Yeah, take the readings. Sai Krishna. 39. 40. 40, Sandeep. 45. 46.
Yes, sir.
Have you done the experiment? 46.
Yes, sir, I'm doing.
Are you getting the readings? How many readings you have taken so far?
250, sir. 50
50.
centimeters.
Right. Go on. Shiv Pratik.
Sir,
Have you done the experiment? 44.
doing, sir.
Are you getting the readings?
Yes, sir. Yes, sir.
Yeah. Do it. If you have any problem, you just call me. Okay, ask me again here. 45, Siddhant. 47. 47, Sindhu.
Sir.
What are you doing now? Which reading you are taking?
30, sir.
30. Okay. 48. Snehali.
Yes, sir.
Have you done the experiment?
Yes, I'm doing it.
Yeah. Can you share your screen?
Yes, sir.
Yes. Show me. Either you are using video or you can share your screen also. So I have given permission to use video. You can show me your readings. Snehali.
Yes, I'm doing it.
Good. Yeah, good. So what is the distance we kept? Length is 5 centimeters. You oscillate it. You are giving a very large angle oscillations. Don't give such a huge oscillations. You have to do for a small angle oscillations. Okay, good. Yes, Nehal, you can continue taking the readings. Huh? Yeah, stop sharing and you can continue taking the readings. Good. Roll number 5, you shared the video screenshot. Good. Arvind. Arvind,
Yes,
are you
sir.
able to take the readings?
Yes, sir.
Okay. How many readings you have taken so far?
3, sir.
Yeah. Ajay, roll number 2. Roll number 2, Ajay. Roll number 7.
Sir.
Have you taken the
Yes, sir.
readings? Yeah, how many?
Sir, I've completed about 4.
4. Okay. So do it quickly. Take all the readings. Huh? Sonia,
Yes, sir.
49.
Yes, sir.
Can you share your video?
Photo or video, sir?
Video. Share your video.
Sir, actually, I'm out of station, sir.
So how are you sharing then?
Network
From
issue.
yeah, from there also you can share. So all others who are doing the experiment, share the value, screenshots. '53, Suvarna. Roll number 53. Roll number 7, you got it. At 5 also 49. Roll number 2, 35, 7. Yeah. So on mobile also you can do this. 54, Swapnarani. Sai Kiran, Dikshit. Kalyan. 34 I got it, 12 I got it. The rest of the students, you need to share your screenshots in the chat box. And the remaining students need to take the readings, take them quickly. Roll number 43. Roll number 43. Yeah, Shiva Pratik, you have shared your screen. I got it. Good. 43, you have not shared your screen. Lamia, you got it. Okay. Yeah, 23, how many readings you have taken on what in the virtual lab?
I took till 95 centimeters.
Yeah, okay, last one you are taking?
Yes. No, I took, so finished.
Yeah, got finished. Yeah. Okay. So you use your the procedure given in the Amta lab, how to do calculations and the rest of the
Okay, sir.
values. Yeah. Yeah, 26 Nihal, I got your screenshot. So those who are doing the experiment and completed taking readings, you inform me that you have completed taking readings on the virtual lab.
Sir,
Yeah,
sir, I have converted all into SI, sir, SI system.
but you're getting only less 5 volts. You should get 5 heads. You should get 50 heads.
No, sir, according to values, you can see that, no, sir, 1 by root mu.
Yeah,
One,
I've checked it. That's why I have a doubt. But again, once again, you do the calculations using calculator and show me. Huh?
okay, sir. After doing calculations, will you mark me more,
Yeah,
sir?
definitely. You just by today evening also you can upload it again. Huh?
Yes, sir. Okay, thank you.
Yeah,
Yeah.
go ahead.